Today I am going to explain one of the several results I have obtained during my research project funded by PPM. This result is about the dynamics of Lorentz contraction. First of all, what is Lorentz contraction? You might have heard of it. It's a relativistic phenomenon. Suppose we have two identical objects. For instance, these two pens. They're built in the same way with the same materials, and you see when they have the same length. Now say that one of the pens stays on Earth, the other pen is on a spaceship going with the speed v relative to Earth. Now, if somebody here on Earth measures the black pen, you will find a certain amount, say 10 centimeters. If he measures the red pen, which is moving with the spaceship, you will find a smaller amount, which depends on the speed of the spaceship. For speeds smaller than very much smaller than the speed of light, this contraction is usually small, but it can become appreciable whenever the speeds involved are comparable to the speed of light in vacuum. So, and the vice versa is also true. If an observer here on the spaceship measures the length of this red pen, which is moving along with him, you will find certain amounts. There is 10 centimeters, as the observer on Earth found the length of the black pen. However, if the observer on the spaceship now measures the black pen, the length of the black pen, you will find a smaller amount, for instance 8 centimeters. This is Lorentz contraction. You see, it is symmetrical. My result is about how this contraction happens in real time. So, suppose that the spaceship at the beginning is at rest relative to Earth. Now, if you measure here on Earth or on the spaceship the length of either pen, you will find the same amount because there is no relative speed. But now say the spaceship accelerates until it reaches a final speed v relative to Earth, and then it stops accelerating. How do we explain that the two pens have different lengths when measured by the spaceship or by the Earth? How does this happen? There are two mechanisms. One is what I call active Lorentz contraction, which is the contraction that the pen making the acceleration is making, and the other is the passive Lorentz contraction. This, if I am on the spaceship together with this red pen, and I observe the black pen here, while I am accelerating, you see nothing happens to the black pen. It's not accelerating, there are no forces involved. And I call this effect that the observer on the spaceship will judge the black pen to be contracting, the passive Lorentz contraction. Passive because nothing is actually happening to the black pen. However, for the red pen, I'm talking about active Lorentz contraction because it is being accelerated. So there are forces involved. And the mechanisms give the same final result, the Lorentz contraction, but the explanation is very different. So let us talk first about active Lorentz contraction. What happens is that in order for this contraction to occur, I have to accelerate this red pen together with the spaceship in a very specific manner. I just cannot apply a force at any point and push or pull the pen. But I have, in principle, to attach several micro missiles to each part of the pen and program each of these missiles in such a way that they give the correct amount of acceleration to each point of the pen until in such a way that no internal stresses occur. Only if I do this does Lorentz contraction happen, active Lorentz contraction happen. And what happens if I don't do this, if I just accelerate the pen in a random way? Well, what happens is that in this case, there will be internal stresses. If the accelerations involved are very large, the pen will break or it will deform. However, if the accelerations are mild, considering that this object is a solid made of atoms which are in an equilibrium position, what happens is that the object will become oscillating around its equilibrium position. So there will be a deformation, there will be some oscillations. At the end of the acceleration period, these oscillations will usually die out because there is always some dissipation, and the pen will reach the final configuration where it appears to be Lorentz contracted when measured from Earth. So this is the explanation of active Lorentz contraction. And what about passive Lorentz contraction? Because as I told you, the black pen is not being accelerated, so there are no forces involved. However, the astronaut on the spaceship which is accelerating will judge that this black pen is contracting while he is accelerating. How does this happen if there are no forces involved? Well, the key is in the principle of equivalence. Principle of equivalence, which is at the foundation of general relativity, was the main idea which led Einstein to formulate general relativity, says that whenever I accelerate, I perceive an equivalent gravitational field. So, for instance, if I am on a car which is accelerating all of a sudden, I will feel a force pulling me backwards against the seat. And this force is proportional to my mass as a gravitational force. This is because inertial mass and gravitational mass are the same, which is another way of formulating the equivalence principle. So, when the spaceship is accelerating, because of the equivalence principle, the astronaut on the spaceship will feel a gravitational field. And we know that there is a Hubble law in gravitational fields which says that objects will move with a speed which depends on their distance from us. So, for instance, farther away galaxies are moving away from us at a speed approximately proportional to their distance from us. The same effect, because of the equivalence principle, happens on the spaceship. It will see points of this black pen here at rest on Earth moving at different speed relative to him. And this is very different from Newtonian mechanics, because in Newtonian mechanics, when I'm accelerating, an object which is at rest in an inertial frame will move with the same speed. Every point will move with the same speed. Instead, here what happens? When the spaceship is accelerating, for instance, the tip of this pen will recede from the spaceship with a different velocity that the bottom of the pen will recede. So the tip is moving, relative to the astronaut, is moving like this. The bottom is moving like this, but slower. So for the astronaut, the pen will start contracting. In his description of the movement of the pen, will start contracting, and this contraction is due to an equivalent of the Hubble law in special relativity, and this explains the passive Lorentz contraction. You see, these are very different mechanisms. active Lorentz contraction, I must plan very carefully the acceleration in such a way that the body does not deform or break. In passive Lorentz contraction, I don't have to do anything because I am accelerating. I am subject to forces, not the pen. So the pen will contract naturally because of the relativistic kinematics. And this is, I believe, an important result because for the first time we have explained how Lorentz contraction actually happens in time. Thank you, and this is all.